Hello everyone. Today we are going to change some of the way that this play area is set up, trying to do it with a script to make sure that we have the cylinders spaced appropriately. Once that's done, we'll see if we can make a prefab out of the cylinder objects with the labels and then spawn them on load. So first I am going to start a script and I'm going to call it setup. I'm going to attach it to the high level, the parent platform object. Keeping our namespace from earlier. Going to get rid of the start function for right now. And add a type of function called gizmos. So we're doing an onDraw gizmos, which is part of the mono behavior. And it lets us draw sort of debug shapes on the screen. And it draws every tick while the game is running. So the first thing we're going to do is just start by drawing a sphere at the center to make sure it's working. So we'll do gizmos dot draw, and I prefer the wire sphere, but they have a solid one as well. It takes a vector 3 position and a size. I'm gonna just set up a float for the sizes up here, and we'll start with 0.025 just to see if how that looks. Add that here, and then another good thing to do is set up different colors to help kind of differentiate. So we can do that by using gizmos.color, and we can set it to black for this first one. All right, I'm going back to Unity and gonna hit play just to see what happens. We have to turn on gizmos to see them. Yep, and there it is. I went a little too small, but we can see it in there. So I'm going to go and try to disable this collider so that we have a little bit less on our screen. There we go. And now we can go back to the script. Make this a little bigger. Now that we have that running, let's write some code to see if we can find the positions for the targets. So first I'm going to make a public int and call it targets and set it equal to 13 because we want 13 different targets in our task. We need a radius or distance from center for each target. That'll be a float, so we're doing a public float. Distance from center, and we can set that equal to, we'll try 4.25. The platform right now is 12, so this would be leaving 1.75 at the edge, and then it should look pretty well. The last thing we're going to do is make a list just to store some of our positions while we calculate where they are. call them positions, and we'll go ahead and instantiate it for now. Okay, so we want to take the circular platform and then figure out how we can evenly space these from the center and a circle. I'm going to write a separate function to start that, and we're going to call it get target positions. That won't take any input for now. And we're going to be adding our list of positions at the end of this. So I'm going to go ahead and clear that list now. Once we have this functioning, we'll come back and clean it up. Now that we have that running, let's write some code to see if we can find the positions for the targets. So first I'm going to make a public int and call it targets and set it equal to 13 because we want 13 different targets in our task. We need a radius or distance from center for each target. That'll be a float, so we're doing a public float. Distance from center, and we can set that equal to, we'll try 4.25. The platform right now is 12, so this would be leaving 1.75 at the edge, and then it should look pretty well. The last thing we're going to do is make a list just to store some of our positions while we calculate where they are. Call them positions, and we'll go ahead and instantiate it for now. Okay, so we want to take the circular platform and then figure out how we can evenly space these from the center and a circle. I'm going to write a separate function to start that, and we're going to call it get target positions. That won't take any input for now. And we're going to be adding our list of positions at the end of this. So I'm going to go ahead and clear that list now. Once we have this functioning, we'll come back and clean it up. We're going to have an angle, and that's going to be equal to the number of targets so we want to make a prefab. Prefab is just a collection of game objects, and typically I find it's best to make a prefab with a parent object that's empty. So let's call it target, copy one of the targets into it, call that, and then we'll add, we have the text, adjust the text so it looks a little, nope, cannot. It's really hard to adjust this text. All right, now we have target set up. We have our resources folder. I'm going to drag the target into the resources folder. I'm going to delete the target from here. I'm going to take this targets make a new folder called prefabs just to hold things. I'm not sure if we'll end up needing to switch back, but it'd be nice to already have that set up. Now I want to keep this target box, so I'm just going to get rid of the targets inside of it. We have this, and we'll add a tag. We'll call it targets, and now we're ready to start trying to instantiate. So we need a public game object, and this is what we're going to make. And at startup, so let's say on awake, if the target is null, we need to set it. And that's going to be set by doing resources dot load, and then we're going to do a string for the name, and the name is target, capital T. Double checking that. Yep. Back to our script. We can start to clean up some of our variables. Move those up top. We'll keep the gizmos for now. On awake, we'll do this once to get all the positions, and then we'll make another function, and let's call it set targets. I'm not sure if we need it, but I think it'd be nice to keep our targets in a list while we're instantiating them, just so that we have some way to access them without having to go through, and this will keep their positions in the order we generate them. Let's call it target collection. And we're going to add these targets so we get the positions, and then we'll set a target on each of them. We don't really need to keep this list, so we can change that to that and remove this list. No, we don't need to clear it. Get rid of that. And then we'll return that at the end. Our draw isn't going to work so well now, but we can fix that by adding that. And now we can set up the targets. I'm going to say this takes a list of vector 3s. And then just call it up here with that. Okay, so we need to make these, and we need to set their positions. We have a prefab, so we're going to instantiate the target. Instantiate takes a transform. We're going to use that targets folder. So we're going to have to find it. And that's going to be find game object by tag, which might be under the game object. Find game object with tag. I really only care about the first one that they return. Double check my tag. There we go. Go back over here. We're going to call that the parent. We have to make a few of these, so we're going to do another for each. We're going to say each vector 3 position and positions. We're going to do this. So we're going to get a temporary game object. We'll call it, and we'll instantiate, and then we'll set the name to the target that we're on. So let's call it target, and then add the number that we're doing. And I'm going to change this loop a little to make that easier. We're going to grab that target again. Now it's missing. Okay, now we're moving. And then we're going to set temp.transform.position to position. Let's go ahead and play that once and see what happens. We're getting this error. I think I know what that is. We forgot to set our game object to the resource we're loading. And we have to tell it that it is a game object that we're loading. That should fix that. Yep, it looks like now we're dealing with some centering issues. To fix the centering issues, we're going to go back to our target and just make sure this cylinder is at zeros. And now we need to fix our text. We can just drag that over, try to center it. There we go. That looks better. Okay, now we have a bunch of targets and they are evenly spaced. Next, we want to update these numbers to display the appropriate numbers. And then we can start adding to the prefab to get collisions. What's nice about this is that now we can use the same sort of formula we're using to generate the targets to generate the optimal paths for the sphere to travel. Oh, because we're spawning them, we have our Z issues again. So I'm going to go back and fix that. What was our ending Y? I'm going to go back to our code and we're going to move this position up just by enough. So we're going to do position plus this minimal Y value. We're going to multiply that by a vector 3 up. Hopefully that is the right way to move that up. We'll find out in a second. That was not. These moved the opposite direction. So let's go ahead and move that, go back to Unity and see if we have that C fighting. Nope, it is solved. To update the name, I'm going to make a script. I'm going to call it fits target, and this will be something we use to record data and keep track of what our targets are doing. We'll open it now. Before I get too far, I'm going back to our resources, opening our target, and adding the script. In that script, we're going to do namespace. Oops. All right, so the first thing we want is to grab the text. We could do this a couple of ways. I think the way I want to do it is just have a public text object. And I'm going to have to remember what the actual class is. So we have a TextMesh Pro text. I'm going to go to edit script. This will give us the actual class. Go back over here. Using TextMesh Pro. And then we want a TMP text. Okay. Let's go back over here. We have our target. I'm going to add the text to it. I'm going to get rid of the text that's on the target. And now on awake, or maybe just as a function, set text. I'll take a string for the text, and then if text is not null, text dot let's call it name. I use text too much. Equals name. We're going to go back to setup, and now we have these things. We're going to want a fits target script, and it's going to be equal to the, well, we're not going to set it yet. We're going to do if and then try get component. It's target out, and the out value is going to be the fits target. This way it's already checking to see if it's null or not. Like if we get a received value, I think we need to do temp.try get component. And this should give it to us, and then we can use that if it's there, and we can set the text to I. And we'll try it again, see what happens. That worked. We're starting at 0, so we'll do I plus 1. I plus 1. Okay, now we have our 13 targets and their text set. Want to update our target to also have its size set. And this was set to 1.5, 1.5. Might be nice to have that at 1, and then we can adjust the scale to 1.5. Get rid of that. So we're going to build a new thing. New shape. It's a cylinder. It remembers what we wanted. We're just going to set it to 1 now by opening this window. Radius of 1. Let's try radius of 5. So our 1.5. Here's our 1. Should correlate with 1 meter. We can sort of see over here that it does if we look at it over one of these squares. We need to center the pivot. There we go. Check to make sure that centered. Just grab my controls. There we go. I'm going to add that to the... I'm not going to add it. I'm going to add the target to here and add that to the target. Go back to the target and accept the overrides. Delete the target. Go over here. Delete that. And after playing with the text target area, we've got it at 1.5 wide, 1.5 tall, and then pivoting at 0.5 and 0.75, and that lets us center it. Let's just make sure it's good there. We might need to set the Z value separate. Yeah. Go back to our prefab. Target the position Z, position Y. And we'll go back to targets just to see what we had it at. 0.055. Target, and then we'll set the Y. Rename this just to get rid of the 1. And we'll call this the label, and then we'll test it. So that works pretty well, except that we're getting a couple of duplicates because the font's too big. So we can set it to auto size with a min of 7, 18. Save those changes. That worked a little better. Going over here just to see what different things look like. Different fonts. Try to... So a 6 looks okay. A 5 looks okay, but a 5 might be starting to get too small. So we'll go back over here. Go to the text. Set this at 5.5. Maybe... To get the text to line up where we want, we're going over to extra settings and we're adding a little bit more padding. to it. And that keeps them so that they don't take up the whole sphere. To get the scale, we're going to find the position of two targets that are nearest each other in proximity, and then find the distance between them and use that distance to help determine what the scale should be. So I'm going to add a function, and I'm going to call it getScale. It's going to return a float, which is the scale. We're going to calculate the positions like we did over here. We won't do it in a loop this time. We only need 2 of them. And then to help us debug, I'm going to temporarily set up these variables so that they're persistent. That way we can use draw gizmos with them. And then we have don't need that code. This first one is just going to be that directly. And then we'll do it one more time for position 2, reusing the original direction. And then let's draw 2 new spheres to see how this works. We'll make them slightly smaller so that if they're on top of an existing sphere, we can still see them. And then we're gonna, let's do green for start, red for end, and we want position 1 and position 2. And we'll do one more thing, which is going to be to draw a line. The draw line takes in a position 1 and a position 2. It works off the same global color. We forgot to actually call the function, so I'm just going to call it, and we don't really need to draw those anymore. There we go. So this is the distance we have between 2 of our points. Now we can use that to calculate the scale we need. So we're going to return a vector3 distance between position 1 and position 2. Set that there, and then the out point right now is the distance between those. We don't quite want that. We want it to be slightly smaller. We need some sort of buffer between them. So we divide it by 2. They should touch each other. So if we divide it by 1.5, they should have a little bit of space between them. And we're going to test this by using our getScale here and setting R based on it. And we'll get rid of these. And that is larger than I wanted. Okay, so half does touch. We want a little bit less than that. Really just trying to manually kind of play with it and see what looks good. I think that works. So output by 0.35. We don't need any of this anymore. Just comment it out. We also don't need these to be persistent. So I'm just going to remove them. And then up here, we're going to get a scale value. We're going to use get scale to provide that. And then we're going to do temp dot transform dot scale, local scale. We're going to say it equals new vector 3. It's going to be the scale we got by the scale we got, and this is just going to be a 1. Let's see what happens. Made it pretty small. I need to play with this output some more. Let's just see what the output is raw. Okay, so if we leave the output as is, it looks like the targets are perfectly sized to just barely touch each other. That works out. Then we want just a small amount of space. So let's say multiply it by 8.5 and try again. That's looking pretty good. Maybe go a little smaller. Yep, that looks good to me. We'll keep it there. The next thing we want to work on is arranging these targets in the appropriate manner. So right now we have them sequentially, and they need to be alternating on opposite ends. So to do that, we're going to add code to a couple of areas. First, we're going to go to our draw gizmos. And we're just going to add some code to draw each of the lines between the segments. The segments being the segments between the targets. Grabbing our list of positions. And I++. Next, we want to draw a line. First, we might need to set up one more variable. Okay, and then we're going to draw a line. So gizmos dot draw a line, and we want to draw it from the last position to the next position. Then we want the last position to become the next position. And see what that says. Okay, so now we can see it starts in the middle, and then it counts 1, 2, 3, and around. What we want to do is try to get a pattern closer to this. Zoom in, where we have start and then it goes opposites. So we're going to go back to our code that makes the positions. And we're going to add a couple of variables. We're going to have a target, and we're going to have a count. It's going to be an int that is okay. So we want to grab the targets, and divide them by 2 to get a number to start the opposite ends with, and then we want to take a target that we're going to use to keep track of our index. We're moving the angle out here, and then we're going to do if I isn't even, we want to have that target equal to the targets plus the count. Right now the count is should be 0 or 1 depending. Count plus equals 1, and then if it's not even, or if it's not odd, we want to have the target equal to an int that is just half of I. We're doing half of I because if we don't, I continues to increase, and that gets us out of the bounds of what we're trying to capture, so it starts generating targets on top of each other. So we're gonna add that there. And there we go. Okay. And once we change this to a division sign, we now have the orientation we want for the targets. So we're now going 1 across to 2 to 3 to 4 back and forth. And that's the order they're going to be in our list. And if we decrease this, it still keeps it in the same order, just with a different number of targets. So if we did a 23, we get a bunch of little targets, but the pattern stays the same. Change that back to 13. So that's everything that's getting covered in this video. Fitts law has a portion of the formula that's based on the distance of the spheres in the circle and the width of the spheres. We have the width of the spheres, and we're basing that on the width that we can make them compared to each other here. We should also set a variable for distance to change the platform size. To do that, we'll be making a prefab out of the platform and setting it up to instantiate the same way that the spheres are.